I'd like to introduce you to a different idea in creating PCB documentation. Our concept is, because we're all doing the same sort of documents, fabrication, assembly, parts list, panel drawings, those drawings have common content, drill patterns, drill charts, top and bottom side views. The information needed to create those views was done when we did the PCB design, so we can combine these two by using the PCB design to create this common content, and we can automate the process of creating PCB documentation. There are several concepts that go along with this. First of all, we wanted to use a what you see is what you get type interface. We no longer want to hide or combine layers to get the final document. We wanted to use the PCB CAD database to drive the documentation, since a lot of the work is done already for you if you're able to use that PCB design database. We wanted to allow unlimited placement of PCB views. No longer are we limited to a right side up PCB view. These can be scaled, mirrored, rotated independently of each other. We wanted to organize the user interface specifically for what we're doing, which is creating PCB documentation. So you'll see palettes that are specific to the type of document that you're creating. We wanted to allow the user to bring in other types of data other than the CAD design, graphics files, reference files, DXF, PDF, text and graphics from other applications. We wanted to use wizards to create common content, so no longer do you have to have a library of different layer stack-ups. Since that information is in the design database, we'll just simply bring in the CAD design and expand to the proper layer sequence and quantity of layers needed in the stack-up. And then we tried to provide a set of tools for everything else, word processing, localized for different countries, drafting tools for drawing inside this tool, dimensioning tools that meet the standards of both Europe, Asia, and the US, tables, being able to drop down a table and then import directly into that table, copy and paste between other Windows apps, object linking and embedding things like an Excel spreadsheet or a Word document directly in our document. We wanted the ability to quickly update the information if the design changes. So since we're using the design to drive the documentation, we can simply re-import the new design to update with all the new information. We wanted to provide multiple viewing alternatives to the finished result. PDF, which is a standard now, we use that. We also have the capability of using our own viewer, which there are 3 different ways that can be used. You can simply save off the database and use our viewer. You can do a pack and release and combine our viewer with the document set and send a single file out. Or you can even create an HTML version of our document set. And the reason we do that is because we want to go beyond paper documentation. While we fully support that now, in the future, electronic documentation, and a lot of you are doing this now, is the way to go. So rather than looking for detail A in this example, I just click on the hyperlink and detail A pops up. And there's hyperlinks inside of detail A that take me all the way out to the parts list and show me the item in question. So this is our goal with this tool. This tool is BluePrint-PCB. What I have here is a document set that is a template for what I want my finished document set to look like. So I create this template. Here is my fab drawing. I want a drill pattern, a drill chart, a layer stack up, and some notes. I actually have a page 2 of my my fab drawing, which I'm doing an assembly array. Now, not everybody does those, but we do have the capabilities in this tool. As a matter of fact, we've automated the creation of assembly arrays to make it much easier for the designer to do it. And then I have an assembly drawing with a top and a bottom side view and some assembly notes. Then I have my parts list. Okay, I have my parts list set to show on this sheet, and it'll expand to the right if it reaches the maximum number of columns. So I can set all this up in advance, save this off, and when I'm ready to start documenting a design, I simply open this file up and import my design. I have many choices as far as importation. ODB++ is what we use from a lot of the major CAD systems, but we also fully support the IPC 2581 spec as well, so you can bring that in. If you're a PADS user, you can bring PADS ASCII in. These are the types of formats that we use to drive our documentation. In this example, I'm going to use some ODB++ from Altium. It's going to ask me which of my documents I want to update. I'm just going to update them all. And now we're going to go back and look at each of the documents and how it got updated by that incoming information. Now we'll look at the fabrication drawing that was created simply by importing the data. So I have a layer stack up here. This is one of our wizards. If we look at the template again, you can get an idea of how it was created. It uses fields in the incoming data to go ahead and populate, and populates not only the substrate thickness, but the copper thickness, and it knows that it's an 8-layer with planes and signal layers. The drill chart's the same idea. Basically, we pull that from the incoming data and match the drill symbols, of course, to the drill pattern. The drill pattern itself is created from that incoming data. We have managers throughout Blueprint that control what our elements look like. So if we wanted to reduce or enlarge the symbols using in our drill pattern, we can come over to the fabrication manager, for example, and actually grow or shrink the size of those symbols. Let's take a look at some of the dimensioning tools inside of Blueprint. So I can come over here and do auto dimension, where I just simply pull off a dimension. I can do point-to-point type dimensioning, where I grab a couple points, snap to them, pull them off. I can do datum dimensioning, where I drop down the datum point and then drop down dimensions based off of that datum point. So let's go through here and drop a few. If you hang a dimension, it'll highlight in orange by default. You can set that highlight color. You can always come and align your dimensions. We do have things like push and shove built in too, so if you need to put a dog leg into your dimension, you can. Our notes are pretty unique inside of Blueprint in that each note is an individual entity that can be called out and placed anywhere on your document. This note is now tied to this call out, so as I move this note around in my note set, it will update with the correct number, and that includes demoting it or promoting that particular note. It's also hyperlinked, so if you get into electronic documentation, there's actually a hyperlink from that note to the call. And of course, if you were to delete a note, the call out goes away. We also have spell check built in, and it is localized for various countries, and you have the choice to add something to the dictionary. Page 2 of my fabrication drawing is actually an assembly array. And real quickly here, the way we work on these is once you've decided how you want this array to look through the format options, you go into an edit mode, which looks like what the finished product's going to look like, and then you can do things like add web routes and add mill tabs to that particular array. We have a drill chart placed here already, and that gets updated as we add drill holes to this. And we even have a mill tab detail that actually shows what our particular mill tab looks like. We'll move on to our assembly drawing. Now on this assembly drawing, I've got a top and a bottom side view. Right now I'm just showing the component outlines and the reference designators. One thing we will do for you in Blueprint is we'll help you optimize the creation of an assembly drawing by optimizing the size of the reference designators. So you can set a minimum and a maximum size and tell Blueprint to go out and create the reference designators, and it will center the reference designator in the component body based on the parameters that you provide here. We have other ways of doing a cleanup as well. You can come in and select a particular reference designator, and you may want to move that off to the side or something, and as you do that, you can just say apply, and it'll do that to all of the reference designators of that type. So there's many tools for helping you work with reference designators. You can also use the ability to change the view, or any PCB view, to highlight a particular component. Let's just say that I wanted to choose a group of components here that I want to put a fill in. I can, first of all, choose the fill. If I want to use a color, I can use that. If I want to use a pattern, I can use that. And actually add a fill to a group of components. There's other things you can do to format individual as well as groups of components, and one of the easier ways to do that is through the PCB view format pane. If I come over here and grab a bunch of components, in this case I'm grabbing everything in that top side view, and go to component properties, I can set the properties for everything, or again, groups of components. So maybe I want to show pin 1, and maybe I want to show it as a square, and maybe I want to show it in red. And I can click OK, and it's going to show all the pin 1s for me. So this is a very powerful part of Blueprint where you can control what your PCB views look like. And there's a lot more controls in there as well. I've got all the nets available to me that I can color code. I've got all the drills, pads and vias. I can go into a particular PCB view, turn on, turn off components, turn on, turn off footprints, turn on, turn off layers. All of these are available to me, again, at a component or a global level. Another feature of Blueprint is the idea of doing a magnified or an exploded view, where you can show a certain area of the design larger and actually formatted independently of any of the other PCB views. And what that means is I can come in here and just draw a rectangle around an area. Then I can say make exploded view out of that area, and what it'll do is first of all magnify it, but then I can go into this and actually format it, and I have full control over what information shows in this exploded view. So maybe I want to show all the route information as well in there. Okay. Then you have control over the transparency, the colors, which things show on top. All of that you have control over in Blueprint. Okay. Our next page is our parts list. And in our parts list we do things, again, helping you with electronic documentation, like hyperlinking to a view of the board from each of the items in the parts list, and we'll highlight them for you there. So if we were to go back and look at our entire document set we've created here, all of this was based on just bringing in data to templates that we've created. Okay, you set up those templates in advance. bring in the data, and a good portion of your documentation is done. Now, I haven't shown you everything that Blueprint can do, but I've tried to give you an overview of what this tool can do and how it can help you in your day-to-day PCB documentation. Thank you for your time.